Hello you guys, Geometry, Module 3, Topic 1, Lesson 1. We're on page 452, and I just want to let you know that in this lesson, this is completely a reshoot. So everything that I'm going to show you on the screen is going to stay the way that it is. We're talking about whether or not the diagrams shown can be described as similar figures. And so if you want to pause the video at any point and then go ahead and just like copy down, you're welcome to totally do that. I'm going to talk through it a little bit here. And so after you've paused and written down, come back and maybe like see what I had to say about the different things so you can know what to do. Now, suppose that the line segment GK is parallel to line segment SM. We're going to describe a sequence of transformations that maps one triangle onto the other triangle. Well, one of the things that we could do is we could trace this triangle, which I did. Sorry, it's not being visible here in this video. And I'm going to rotate it all the way around. So in that rotation by 180 degrees, these 2 points, G and K, are going to become here. Now, K is going to be on the other side of that line segment. G is going to move over here. And so this little triangle-like impression has been rotated 180 degrees. The second step in a sequence, we need like two to call it a sequence, otherwise it's a one thing. The second step is to do a dilation, and that's one of the key things about transformations when you have similar figures is there's a dilation that's involved. Specifically, defining the dilation needs to have a center, H. So once this triangle has rotated around to H, then we're going to increase its size with the scale factor. And I had measured with millimeters, centimeters, etc. to figure out that the full length of HS divided by the length HK is about 2.2 in terms of scale factor. Like scale factor is a multiplication process, and you can use the opposite of multiplication to division to figure out how big that scale factor adjustment needs to be. That's number one. One thing that I did as well in the middle here, this note, it says translations will show. So in a translation, angle size is going to be preserved. So angle S and angle K are going to have the same angle measurement, therefore they're congruent. And the same thing is true with angle M. When angle M, G, when G is rotated around, we can then slide it down to see that angle G and angle M, they match perfectly. And so therefore there is congruence there. In part 2, we're going to say that what if we knew instead that angle G is congruent to angle S, and we want to describe a sequence of transformations that maps one triangle onto the other. And when I looked at that one, I really was legit confused for a minute here, thinking like, how am I going to get angle G and angle S to match when in the first question it was G and M that matched? And then I realized if I draw this flat line called an auxiliary line, and it's going to be perpendicular to GK and SM, when you use that line to reflect the small triangle HGK over it onto the bigger triangle, and then use a dilation, we do actually wind up showing that angle G is congruent to angle S. And it's the same sort of argument or conversation about how much of a dilation is it, what's the center of the dilation. And so really this is just a reiteration of what we said in question 1. 2 part A, right? This part right here is also the same for down here. Because once they line up, they line up. And we can make the same sort of statements. Now, last of all, what I noticed, I believe there's a typo here, so if your book doesn't have this written as a fraction, it really is meant to be a fraction. The key thing about similar triangles is that we can show that there's proportions involved. So a proportion would be like comparing sides that match to other sides that match. And when we do that, we'll notice that the ratio created by these two sides, or here, these two sides, is going to equal the ratio created by the other two. And ratio is one way of being able to express a fraction. So the fraction of matching sides, that one and that one, is going to be the same sort of fraction as ones that match these two sides. And so what we're trying to show here is that maybe you take the pre-image number and you divide by the image number, and it's going to equal the pre-image number from another side divided by the image that it corresponds to on the other side. That's it for page 452. Thank you so much for sticking back around. Again, apologies that this is a reshoot of the lesson. Next up for us is question 3 on page 453, so stick around and I'll see you in the next episode.